All right, Honors Algebra 2. Here we are. This is your video for Thursday, the 21st. We are finishing up your test review for Chapter 3, Part 1. I've begun to put some things in for into Skyward just to let you know when things are going to happen. All right. I will be out next week as well, but it should be good to go for Monday, November the 1st, to see you again on that day. Obviously, the Chapter 3 Part 1 game plan is going to be due the next day, most likely, or Wednesday. I forget when I put it. Chapter 3 Part 2 game plan is going to be due. And you're going to be like, what? You've not talked about it. You're right. That's what we're doing next week. So I've got the TI-84 graphing calculator at my house. Shout out to Mr. Palmer for bringing that by to me. Thank you very much. So you're going to have this. I sent it to you already. Print it. Have it ready. Either print it at home or print it to the IMC. Have this ready to go. All right. I'm going to hand write it, but you'll be able to follow along. The first part's pretty easy. We won't need the graphing calculator on Monday, but I'll tell you when, and then you just go to my little calculator, pouch there, and grab one and use it. All right, and that'll be due. We can talk about this while I'm gone. It's no big deal. That'll be due when I come back. Again, I think it's in Skyward, so look there. All right. So hopefully you're watching these videos, because I'll give you like one day to ask and clarify some questions. And then we are moving on. We're not missing a beat, all right? You sent me all that Goggins motivation, so I'm ready to go. You guys better be too. So let's start here. Solve the system. This is a good one for your test review. This is a by x. Look at it. The x's are... You either have 3 or negative 3 with the x's. By x. I added equation 1 and 2 together. That's going to give you a single y minus 2z is equal to 1. That's equation 4. Then I added 1 and 3 together. Yes, you can do equation 2 minus 3, but if I can add, I'm going to add. Add 1 and 3 together, and you get 7x minus 13z equals 3. All right, so what do we want to do? Notice how if I multiply equation 4 by 7, the y's will be the same. So, I'm going to have to subtract here. That's no big deal. So my equation 4 is just going to look 7 times larger, all the terms. And my equation 5 goes right there. The y's will now cancel through subtraction. Be very careful when you subtract negatives. Z is a negative 4. That seems pleasant enough. I go back to the original equation 4, and I plug negative 4 in for z. I get y is a negative 7. And I'm going to go back to, which one did I choose? I chose equation 2. Just label, organize yourself well. 3x minus a negative y plus 3z is equal to 4. And you solve to get x is 3. Pretty pleasant answers. All right? Pleasant answers. 3 pounds of chicken and 5 pounds of beef, $55. C for chicken, B for beef. 3C plus 5B is 55. That's what that first sentence says. Then 7 pounds of chicken and 3 pounds of beef costs $59. That second sentence is right here. 7C plus 3B is 59. What do you want to get rid of? I chose to get rid of beef. All right, multiply by 3, multiply by 5. Subtract. You have a negative. Uh-oh. Cost of chicken can't be negative. Well, it's not because you have a negative over here. $5 pound, or $5 a pound. And then plug 5 in for C. And I used equation 1 for that. And beef is 8 pounds. $8 a pound, that is. All right. Excellent. One of you literally just sent me an email. Fantastic. All right. What is the point of intersection of the two lines? Folks, I know this is worded differently. Sometimes the ACT asks you some really easy questions that are worded in a way that I don't use, and we just like, oh, I've got no idea. This couldn't be easier. I literally have given you an answer for x. Just plug that answer in for x and figure out what y is. The intersection is a negative 7, negative 15. All right, that could not be easier. This one is from the ACT. Now let's think about it. What value of b would give the following system infinite solutions? Infinite solutions means all real numbers. Well, just look here. What do I want to do? If I want to eliminate anything, if I want to eliminate the x's, I'd have to multiply by 5. If I want to eliminate the y's, I'd have to multiply by 5. Anyway, if I multiply everything by 5, 10x, 10x, 35y, 35y, everything's the same. Infinite solutions mean you have the same two equations twice. So set 60 equal to 30b. B is 2. That one is not very difficult. And the ACT usually asks you a system of equations question. And sometimes it's some pretty easy. All right, so know how to do that page. Here is another good page right here. Talking about 13. 2 welders worked a total of 56 hours on a project. The first welder is the one that made 27 an hour. The second one's the one that made 34 an hour. The gross earnings were $16.87 for the job. Those are your first two equations. The individual that made 27 an hour, the hours they worked, plus the individual that made 34 an hour, the hours that they worked equal 56 hours. For every hour that this person works, $27, plus for every hour that this person works, $34. And that equals $16.87 charged for labor. All right, so what do I want to get rid of? I chose to take equation 1, multiply it by 27. Now I put that, I'm not doing anything with equation 2, so this new equation 1, I just put under equation 2. The order doesn't matter. All right, everything in equation 1 was multiplied by 27. And then I subtract. 7y is equal to 175. Y is 25. Put 25 in for y. X is 31. All right, here we go. The farmer and the feed. One is a 6% digestible protein. The other is an 18%. That's X, that's Y. And Yogi is going to find himself in the bathroom again. Goodness. There is no escaping Yogi as I am relegated to the first floor. And we're 7 minutes in. All right, we're back. Sweet Yogi is taking a timeout in the bathroom. All right. Because he will not bark at anything that passes outside, and today is trash pickup day. So, Yogi's fine, he's safe, the bathroom is big enough, he'll be rescued soon. X plus Y is equal to 100. All right, for every pound of X, 6% is digestible protein. For every pound of Y, 18% is digestible protein, and that is 100 pounds at 15%. All right. 0.15 times 100 is 15. I'm going to multiply everything here by 100, and that is finally my new equation 2. All right. So I'm going to take equation 1. I'm going to multiply everything in equation 1 by 6. That's my new equation 1. My new equation 2 without the decimals. There we go. I'm going to subtract 2 equations, get rid of the x's. Y is 75. X plus 75 is 100. X is 25. 25 pounds of the 6%, 75 pounds of the 18%. Oh man, that lighting, great spot. What is the point of intersection? All right, we've done this one before. X is a negative 3. I'm going to plug negative 3 in for Y. Y is a negative 19. I'm plugging negative 3 in for X to get Y. What will be the value B so that the following system has infinite solutions? We've seen this one before. So 2x, if I multiply by 4, I get 8x. 3y, if I multiply by 4, I get 12y. 20 times 4 is 80. 8x, 8x, 12y, 12y. 8b must equal 80. B is 20. All right, then we're we're almost done here with what I want to discuss. Again, I will leave some of these questions for you so you can ask me when I return on Monday the 1st. Find the x-coordinates of the solution to the following. Okay, it does say just solve for x, so what did I do? I moved. So if you ever get something that just says solve for x, y equals 8 minus 4x. All right, so you know what y is, so I'm going to plug that in for y. I don't know why that took me long. I'm going to plug that in for y. Now I have 2x minus a quarter of 8 minus 4x, because that's what y is, equals 6. And I do a little distribution, and I move the negative 2 over, and I get x is equal to 8/3. Okay? There you go. Now, 19's odd. I don't know when I originally had this at Mount Olive if I copied it down wrong, but none of those answers are correct. This one came from the ACT. So here's what you do. You divide in this first equation everything by 2. So you have y equals 3 over 2x plus 3. Divide everything here by negative 4. They're not two parallel lines because the slopes are not equal. I don't know if I made a typo, if that was supposed to be a 4y. They're not parallel. A single line with negative slopes. No, they're not the same line. They're definitely not the same line. They're not perpendicular, so it's none of the above. That's how you would handle it, though. Get everything in slope-intercept form and see what is true. All right, so we're getting close to the end now. If I have this highlighted here, i.e. in sort of a rectangle, I want you guys to try those. So try those 2, 3, and 5. Try those on your own. We'll talk about them when I get back. There's the answer for 1. What couldn't be easier? The y's match up perfectly. There's your answer for 4. Notice I multiplied everything by 3, and then I put it right below. Then I worked with those two, and I subtracted. And there's the answer for 6. But try 2, 3, and 5 on your own. I will expect for you to have those done when I see you again. All right? Have those done for me. 2, 3, and 5 on that page. I'm going to ask you, do you understand them? What's the answer? On Monday the 1st. All right, on this next page, do number 7. 8, there's a mistake. Because the x's match up perfectly, and if you subtract, you get 7y is equal to negative 32. So just cross out 8s. Nope. 9, so very easy. Set equal to 9's about the easiest substitution we could have. Then you're going to do 10 and 12 on your own. Ooh, 10's got a special answer. There's the answer to 11, some nice substitution. There's 13 and 14. Try these on your own as well. All right. Those would be really good to try. Now notice in 14 so 13 should be easy. Bye bye x. Those match up perfectly. Add 1 and 2 together. Add 1 and 3 together. And then 14, you want to say bye z because equation 2 doesn't have a z. So take equation 1 and 3 and subtract them. Then you have 2 equations with no z. All right, help yourself out there. And then yesterday we talked about this. I said try on your own, but I've given you the answer here for 16. This first equation, y-intercept of 4, down 3 over 1, down 3 over 1, a shade below. This next one, y-intercept of negative 1, up 2 over 1, up 2 over 1, up 2 over 1, a shade above. Where is the intersection? The overlap, not the intersection. Where's the overlap? Right there. So that's how 15 rolls. Do 15 like that. Again, you're doing 15, and then you are doing 17. And we have 18. 1 is your y-intercept, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Down to 1 left, down to 1 left, down to 1 left, down to 1 the left. Where, go, you're not shading. Why did I have all those points? Because I do want to see where this intersects. Negative 8 for the next one is your y-intercept. Don't go down 5 over 2. That's not going to work. Instead, go up 5 over 2, and ding, ding, ding. They intersect right there. The intersection is 2. No, it's not. It's not negative 2. Or it's not 2. It's negative 2. Negative 3. That is in the third quadrant. Both are negative. All right, folks. That page is too easy. This one is so very easy. You don't need to do that. And lastly, do try this last page. 14. We might have done 14. Some of these you might have done already. Bye by X or bye by Y, either way. This one definitely bye by Z. So this last page. And folks, on Monday, the 25th, you will have a new notes video for the matrix, and that's a pretty easy one. And we will just keep rolling because we're going to stay on track, right? Because you can't stop us. Great. All right, folks. Have a good weekend. Stay healthy. Be safe. This is Yak Math Videos signing out.